All right, here we go. It's been a minute or two since I filmed my last calculus video, so I hope that all this comes back to me. This first question that we're going to look at, or this first question I'm going to film, is from the 2018 AP exam. It's question number 3. So if you were a calculus student in May 2018, this would have been your first calculator inactive question to work on. So here we go. We've got the graph of g given to us. It says the graph of the continuous function g, the derivative of the function f is shown above. The function g is piecewise linear for -5 less than or equal to x less than 3, and g of x equals 2 times x minus 4 squared for 3 less than or equal to x less than or equal to 6. Okay, they just gave us a whole lot of information. Let's make sure we know what's going on. We've got the graph of g, and so I like to write g in a whole lot of places so that I don't mess this up. We can see that the graph is continuous. The derivative of the function f, so g is actually the derivative of f. That's what they said right here. That may be helpful later on. It probably will be, but I don't know yet. The function g is piecewise linear, so all of these pieces that we see are linear, except for this part over here, which is shaped like a parabola. Okay. In part A, they tell us that f of 1 is equal to 3, and to find f of -5. So f of 1 is 3, and I need to find f of -5. For those of you that are familiar with this, they gave me the value of the function at one point. They're asking me for the value of the function at another point. This is a classic fundamental theorem of calculus problem. The FTC says that the value of the function at -5 is equal to the value of the function at 1 plus the integral of the derivative of the function from 1 to -5. F of -5 equals f of 1 plus the integral from 1 to -5 of f prime of x dx. Now you might say, wait a second, hold on, how am I going to figure this out? There's a whole lot going on here. To find the integral from 1 to -5, that means find the area under the curve, but I'm going from +1 to -5. Those limits are in the wrong order. Well, that's something that we can fix. So I can write this as f of 1 minus the integral from -5 to 1 of f prime of x dx. I'm being asked to find the area from -5 to 1 under the curve f prime of x dx. You might say, but wait, I don't know what the graph of f prime of x looks like. Yes, you do. We knew from earlier that f prime and g are the same thing. So all I need to do is find the area bounded by the graph of f prime from -5 to 1 and the x-axis. So here's -5. Here's +1. I need to find that area. I see that I'm going to have some negative area. We're below the x-axis. And I see that I have some positive area above the x-axis. So let's put this all together. F of 1 is 3 minus the area from -5 to 1. Well, what do I see here? I see a trapezoid, and the area of a trapezoid is 1/2 the sum of the bases. Here's the first base. Here's the second base. Those bases have to be parallel to one another. The first base has a length of 3. The second base has a length of 4. And then I'm going to multiply that by the height, 1, 2, 3. And keep in mind that that has to be a negative value because we're below the x-axis. Now I'm going to add on the area of this triangle over here. Area of a triangle is 1/2 base times height. So that's 1 times 2, 1/2, 1 times 2. You can simplify this if you want to, but there is absolutely no need for you to do that. For those of you that are curious about the simplification, 3 minus, let's see, 3 plus 4 is 7, times 3 is 21. 1/2 of that, I'm going to get -21 over 2, plus 1/2 times 1 times 2, well that's 1. If I distribute the negative through, I get 3 plus 21 over 2 minus 1, getting a common denominator that's going to be 25 over 2. I would hope that you would stop here. That's considered a safe stop. When all your values here are numbers, there's no need to go any further with the simplification. All you could do is possibly throw out a point that you just earned. I wouldn't want you to do that. They awarded points for setting up this integral here, the integral from 1 to negative 5 of f prime of x dx, and then 1 point for getting to the numerical answer, for a grand total of 2 points for part A. I would think that that's a pretty standard kind of question that most calculus students at this point in the course should feel pretty okay doing. Let's keep going. In part B, they ask us to evaluate the integral from 1 to 6 of g of x dx. That means they want me to find the area underneath the curve from 1 to 6. So from 1 to 6, g of x dx, g. We've got the graph of g. This time we want the area from 1 to 6. So let me get a different color. To find that area, well, let's see what's going to happen this time. Everything is above the x-axis, so we have positive area. That's good. I see this part over here. Well, that just looks like a square. I've got this shape here. That's not a triangle. That's going to be a little tricky. And this other part over here. The key to evaluating this integral, let me scoot my work up a little bit here, is going to be to actually look at this as two different integrals. If I want to find the area from 1 to 6, let me find the area from 1 to 3, and then add on the area from 3 to 6. And the reason why I'm going to break it up in this way is that the area from 1 to 3, well, that's just a square. I can find that easily enough. The base is 2, the height is 2, I get an area of 4, plus the integral from 3 to 6 of g of x. And they told me that g of x from 3 to 6 can be written as 2 times x minus 4 squared dx. Okay, we've made some progress. We went from one integral to two different integrals. The first integral we could evaluate using basic geometry. The second integral we're going to evaluate using our calculus techniques. So let's see, what can I do? The 2 is a constant. I can factor that out in front. I've got x minus 4 squared dx. Now, maybe you want to think about doing substitution. That's okay, and you could let u equal x minus 4. But since this is a linear expression, it's being squared, the antiderivative can be found just by adding 1 to the power, so x minus 4 cubed, and then dividing by 3. You've still got the 2 in front, and you've got the 4, and you've got to evaluate your antiderivative from 3 to 6. You'd get this exact same expression if you chose to do integration by substitution. I'm just going to get there a little bit faster. Okay, from here now you're going to evaluate, so it'll be 4 plus 2 times 6 minus 4 cubed over 3 minus 2 times 3 minus 4 cubed over 3. Again, it is perfectly acceptable to stop right here. You get all the points. If you want to go further and simplify, and I would not encourage you to do this, but let's do it. 6 minus 4 is 2. 2 cubed is 8 over 3 minus 2 times 3 minus 4 is negative 1. Negative 1 cubed is negative 1 over 3. We get 4 plus 16 over 3 plus 2/3. Well, that's really 4 plus 18/3. 18/3 is really 6. 4 plus 6 is 10. They awarded 3 points for this problem. The first point comes in for knowing to write the integral as two separate integrals. Another point comes in when you successfully find the antiderivative of x minus 4 squared by substitution, by sort of guess and check, and then 1 point for the evaluation, which would come in right here, or for the simplifying. But again, look at how much work you had to do and how many maybe careless mistakes could creep in and what they would do is they would withhold this third point from you. So free response part of the exam, don't simplify, just get there and move on, and that gets you 3 points. All right, let's look at part C. In part C, for the interval -5 less than x less than 6, on what intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Well, what do we know? They want f to be increasing and concave up. Well, I don't have the graph of f. Oops, let me scoot that up. I don't have the graph of f in front of me. I have the graph of g. What I want to remember is that f prime is equal to g. Well, if f is increasing, then that means f prime, which is g, has to be positive, and f prime, which is g, is, if f is concave up, then f prime is increasing. So I'm looking at the graph of g and asking where on the interval -5 to 6 is the graph of g positive above the x-axis and at the same time increasing. If I look carefully at the graph, I'm below the x-axis over here. I'm on the x-axis from -1 to 0, and I don't start being above the x-axis until I get to 0. From 0 until, what is that, 1, I can see that my graph of g is positive and increasing. So I'm going to say from 0 to 1. I'm not going to include the 0, and I'm also not going to include the 1. So open parentheses on both. Is there any other place where g is positive and increasing? Well, that's going to be also on this interval from 4 to 6. Yep. They awarded 1 point for the intervals. They awarded 1 point for the justification, for a grand total of 2 points. Again, I would hope that this would be a pretty standard question that would make us all feel pretty good. Let's finish it off with part D. In part D, we're asked to find the x-coordinate for each point of inflection of the graph of f. All right. So if f has a POI, a point of inflection, that means that f changes from concave up to concave down, or from concave down to concave up. That's the behavior of f. But again, we don't have f in front of us. What we have is g, which is f prime. So f prime, which is g, would have to make a change, so triangle for change, from increasing to decreasing, or f prime changes from decreasing to increasing. Again, I look at my graph of g. Where does g change from increasing to decreasing? I'm horizontal, I'm increasing, I'm horizontal, I'm increasing some more, I'm horizontal. I don't actually start to decrease until 3. But the problem with 3, and I think this is a tricky one. At x equals 3, I'm not making a change from increasing to decreasing or decreasing to increasing. At 3, I'm going from horizontal to decreasing. So let's keep going. Not at x equals 3, but right over here at x equals 4, the graph of g changed from decreasing to increasing. That happens at x equals 4. The graph of g actually never changes from increasing to decreasing on the interval that we're interested in. So our final answer is going to be x equals 4. And how did they award points? They awarded a point for x equals 4, and then they awarded the point for the justification. This one's definitely a little tricky because that x equals 3 is going to be a place where, honestly, if I was taking the test, I'd have to stop and think, did my graph G change from increasing to decreasing right at this point? No, it actually didn't. It went from being horizontal to decreasing. That's why it doesn't count as having a point of inflection there. But at x equals 4, my graph did change from decreasing to increasing. Part D is worth a total of 2 points. So that was 2 points on part A, 3 points for part B, 2 points for part C, and 2 points for part D for a total of 9 points. Hope that went well, and hope you learned a lot. Bye.